Welcome to Endless Learning Training Series, the membrane-based desalination technology.
In this video we will study about Silt Density Index (SDI) in seawater reverse osmosis plant.
What is silt density index? Why is silt density index important for RO membrane plant? What is use of silt density index? What is recommended SDI value for RO membrane? What is procedure for silt density index measurement? How is silt density index reduced? What is silt density index, SDI? Silt density index is a test that indication of the particulate and colloidal fouling potential of the saline source water. It is a widely accepted method. The silt density index also be called as fouling index, FI.
Why is Silt Density Index (SDI) important for RO membrane plant?
SDI indicate that the pretreated influent is not suitable for SWRO treatment due to high particulate content in the source seawater. SDI indication about fouling potential of suspended solids. SDI predict the rate of fouling in RO systems.
RO unit startup only allowed if RO feed water SDI less than 5.0. For good RO performance the SDI shall be below 3.0. What is use of Silt Density Index (SDI)?
SDI is mainly indicative of the content of particulates and colloids in the source water that can be retained by such size filters. SDI test is used to predict and thus prevent fouling of the RO membrane surface.
What is recommended SDI value for RO membrane? Depending on the membrane manufacturer, the typical recommendation is to maintain a SDI value of 3.0 to 5.0 for feedwater to a reverse osmosis system.
SDI.
What is procedure for Silt Density Index (SDI) measurement? The SDI test entails forcing water through a small diameter, 47 mm, 0.45 micron absolute membrane filter while maintaining a pressure of 30 psi. The time required to pass 500 ml at the end of 5, 10, and 15 minutes is taken and used to calculate the unit-less SDI value. What is procedure for Silt Density Index (SDI) measurement?
SDI test procedure.
The initial time required to fill a 500 ml graduated cylinder is measured and recorded as T0. A measure of the time required to collect 500 ml volumes is noted again at 5, 10 and 15 minutes after the initial start. These times are recorded as T5, T10 and T15 respectively. What is procedure for Silt Density Index (SDI) measurement? The SDI measurement is a manual measurement which is described below. The SDI apparatus consists mainly of the following: V1 inlet isolation valve, PCV1 pressure reducing valve, PG01 pressure indicator, H001 membrane filter holder, vessel with marks at 500 ml, V02 isolation valve for draining. Prior to any SDI measurement the sample pipe shall be flushed thoroughly to get fresh water to the device. 1. Close the inlet valve, V1. 2. Open the 3 screws from the filter holder and insert the membrane filter. 3. Put O-ring of filter holder on the membrane filter and put water on the top by opening slightly the valve V1. The filter paper shall be completely covered with water. 4. Close filter holder with 3 screws. 5. Open the inlet valve V1 fast and start the stopwatch. 6. Check and readjust the pressure to 30 psi 207 bar. 7. Note the time for a sample volume of 500 milliliters. 8. Continue the filtration process for 15 minimum. 9. After 15 minimum, note the time for the sample volume of 500 milliliters. 10. Then close the inlet valve V1, open the membrane filter holder and remove the membrane filter, assemble the filter holder and keep a small flow to the apparatus if no measurement is taken for SDI test results to be accurate. The feed line to the kit must be connected to the raw water line representative of the water to be treated by the RO system.
It is also important to ensure that all of the air is purged from the apparatus and that the feed pressure is adjusted to 30 psig.
What is procedure for Silt Density Index (SDI) measurement? Calculation of Silt Density Index (SDI). The SDI value is then calculated using the following equation: SDI equals 1 T0 T15 100 T0 equals initial time in seconds required to collect a 500 milliliter sample. T15 equals time in seconds required to collect a 500 ml sample after T15 min. T equals total test time in minutes up to start of second sample collection time measurements, normally after 5, 10 and 15 meters minutes.
Plugging factor. The plugging factor is another important parameter for the measurement of suspended solids, measured in percent. When a value of 100% is achieved means the filter is completely plugged. The membrane is plugged, whereas with 0%, the membrane is completely free for suspended solids. In case of higher PI, the measurement shall be repeated with either shorter sample time or smaller sample volume. For other applications, if raw water is measured, the sample volume shall be 200 milliliters and the sample time T shall be 5 minutes.
Calculate the plugging factor after 5, 10 and 15 minutes as follows: PF5 equals 1 T0 T5 100 PF10 equals 1 T0 T10 100 PF15 equals 1 T0 T15 100. The SDI value is then determined at each interval as SDI equals PF(T). T0 equals initial time in seconds required to collect a 500 milliliter sample. T15 equals time in seconds required to collect a 500 milliliter sample after T15 min. T equals total test time in minutes up to start of second sample collection time. Example: your time measurements indicate a T0 of 1 minute and T15 of 4 minutes. Plugging factor is then calculated as PF equals 1/4, 100 equals 75. The SDI is then calculated as SDI equals 75/15 equals 5. Silt Density Index (SDI) measuring range. The maximum 5-minute SDI equals 100% divided by 5 minutes, which gives you 20 SDI units % decay per minute. The same with 10 and 15 minutes lowest SDI value, which is most often at 15 minutes high SDI. It's often useful to measure the SDI at 5 and 10 minute intervals.
SDI above 5 means the plugging percentage is even higher. SDI value less than 1 then high quality water.
RO permeate SDI value less than 2 then minimal or no pretreatment required. SDI value less than 3 then water suitable for RO membrane. SDI value greater than 5 then need further pretreatment. SDI value greater than 6.7 then not suitable for RO membrane.
Visual inspection SDI pad and SDI values. Reddish-brown discoloration of SDI test pads indicate overdosing of iron-based coagulant. Black or dark brown pads indicate due to high content of manganese. Solid particles observed on SDI test pads due to broken nozzles of dual media filters. Brownish, likely too much ferric chloride is dosed as coagulant. Sandy beige ferric chloride dosing might be too little. Silt Density Index, SDI, location on SWRO plant. Silt Density Index, SDI, checked at seawater intake, after dual media filter, and after cartridge filter. Seasonal influence of temperature on SDI. SDI increase in summer and decrease in winter. How is Silt Density Index, SDI, reduced? Pre-treatment process has been determined based on the composition of the seawater intake. Its function is to reduce the SDI from 10 to 3 by removing visible solid particles and suspended materials. SDI is reduced with dual media, anthracite and sand, filter units. Media filtration, rapid, green, sand filtration, for SDI below 6.0. Coagulation, sedimentation, or flotation, rapid sand filtration used for higher SDI value. Beach wells intake produce usually water with low turbidity and low SDI. Ultrafiltration, UF, membranes used in pre-treatment are able to produce water with very low SDI values. Pre-treatment processes with dissolved air flotation, DAF, and or ultrafiltration, UF, used to lower SDI values, but according to seawater area condition.
Thank you for watching this video.